Pluto continues to divide scientific minds. Since it was discovered in 1930, the celestial body has been a permanent member of our planetary system for over 75 years. However, the galactic reversal occurred in 2006, as more and more Pluto-like objects were discovered in the Kuiper Belt. As a result, Pluto was placed in the newly opened ranks of dwarf planets, of which it has since become the largest known representative. The breathtaking images captured by the technical equipment during its mission thus represent the last images of the former planet for an indefinite period. So today, let's take a closer look at the fascinating photos and discoveries that New Horizons captured and revealed. Before we begin, don't forget to like and subscribe to this channel for more intriguing videos like this. And be sure to watch this video to the end. Therefore, anytime we upload a new video, you will be notified so that you won't miss out on interesting videos from us. Let's begin, without further ado. So, to study Pluto at close range for the first time.
We've seen images of Pluto from Hubble, from ground-based telescopes, but this is the first time we're ever going to see anything on the surface.
The transmission of data collected by the unmanned spacecraft over Pluto during this period ended on October 25, 2016.
At the building here on the APL campus where the science team is working. The science team assembled 5:45 this morning for a chance to see that best image of Pluto and to react to it and to have a little bit of a scientific discussion. And I think we're going to give you a peek into it if we can cue it up.
Since then, New Horizons' primary mission has concluded, and when a spacecraft will next set off for the dwarf planet is currently only written in the stars. A brief overview of Pluto. To understand why Pluto was banned from our local planetary system, we must first answer a basic question. What exactly is a planet according to the current definition of the International Astronomical Union? To be included in the corresponding ranks, a celestial body must meet 3 requirements. Its orbit had to take it around the Sun. It had to have an approximately spherical shape, and it had to be the dominant celestial body in its orbit, or, in other words, it had to have cleared this orbit of other objects by its gravitational field. It was only this last point that sealed Pluto's planetary end. The dwarf planet is significantly smaller than the Earth's moon, which has a value of around 2159 miles in this category, while our planet takes 365 days to complete its orbit around the Sun. Pluto needs over 247 years to complete the same task. While the dwarf planet travels through space, it is sometimes 49.3 astronomical units away from the Sun, but it never gets closer than 29.7 AH to our central star. The astronomical unit corresponds to the approximate distance between the Sun and the Earth, which is approximately 90 million miles. Pluto's bitterly cold temperatures are also due to its remote location from the Sun. On average, the thermometer here drops to -404 degrees Fahrenheit. In terms of structure, the dwarf planet can be compared to Neptune's moon. Triton, a massive rocky core, is followed by a layer of water ice, which is surrounded by nitrogen ice. We now know that Pluto is not traveling through space alone. It is accompanied by at least 5 natural satellites. In detail, the 2 celestial bodies have a double-bound rotation, which means they always face the same side, with an average diameter of about 745 miles. Because Charon is half the size of its cosmic counterpart, experts have been debating whether it would not make more sense to refer to the double system for some time. Pluto, with the fascinating surface of the dwarf planet, greets us on an area roughly equal to that of the South American continent, where we find the most diverse plains and formations ranging from massive ice surfaces to the mighty 11,500-foot high Norgay months. Unique reliefs reminiscent of snakeskin Pluto demonstrate the natural diversity of the cosmos in spectacular images. After a 9-year journey, New Horizons swung into the realms of Pluto on July 14.
The images that we've been getting and the science we've been getting from Pluto is really just been, more than amazing, and proves definitively a scientific theory that science never sleeps.
2015. Giving us a detailed look at the remote dwarf planetary world for the first time in history during its research mission. The spacecraft approached within 7,800 miles of the celestial body,
This is a model of the spacecraft on the mission to Pluto. It's packed with instruments to measure everything from Pluto's atmosphere to its structure to its surface. Here are the cameras, infrared, and around this side, high resolution for the close-ups. The antenna beams everything back here. Because the spacecraft is now so far away, that job will take 16 months in all. Today is just
capturing countless high-resolution images of Pluto and its companion, Charon. As a result of the enormous distance that separated the $700 million piece of equipment from Earth, it took more than 15 months to transmit all of the collected data, but it was worth the wait. First, consider the color-enhanced overall view of the dwarf planet. While the image astounds us with its incredible detail, it is also of unparalleled value to scientists due to the differently colored regions. Experts can explain how their chemical composition is formed. As a result, the correct area can be seen. Thanks to New Horizons, we know that Pluto is frequently the scene of an exotic ice flow. Close-up images of the ice sheet show that the frozen mass has moved over time, much like terrestrial glaciers do.
It's a very successful flyby of the New Horizons spacecraft through the Pluto system. And we're just 10 days from that, and yet we've only had about an opportunity to see about 5% of the data. As many know, we stored that data on board as we flew through the system, and it's just now starting to come back.
Furthermore, the data collected suggests that Sputnik Polynesia's center is rich in nitrogen, carbon monoxide, and methane. The center's frigid surface temperatures allow these frozen-out materials to move back as if by magic, which is why we can enjoy the following image. As you can easily see, the captured landscape is rich in detail, and we can see a rugged mountain plain on the left edge of the image from a distance of approximately 11,000 miles. The Norgay months have already been briefly mentioned, but if we now cast our gaze toward the horizon, we will notice the Hillary months, which tower up to nearly 11,500 feet above the landscape. We can also see the impressive dimensions of Sputnik Planitia here, where the icy plain in the Tombo Regio covers an area of approximately 650 by 500 miles above these strangely familiar-looking formations, and the dwarf planet's thin atmosphere becomes invisible. This high-resolution image demonstrates how unusually sharp the subdivision of individual structures can be at times. On the left are the so-called allergies months rugged, highlands made mostly of frozen nitrogen, greeduts once more on the right, explaining why the individual plains are divided into different segments and adorned with numerous pits. Snakeskin is a mystery that has yet to be solved. At first glance, the next photograph appears to show only an unusually shaped formation with a striking texture reminiscent of a snake's skin. However, from the expert's point of view, the photo could provide us with significantly deeper insight, namely into the conditions of the proto-solar nebula from which our solar system once emerged, which is located in the Tartarus dorsal region. An elevation model created by New Horizons shows that the snakeskin formations have a height of about 1,000 feet. Rising structures, however, should raise some eyebrows among experts due to spectroscopic measurements of the region. According to the data, the area in question is primarily composed of methane with a small amount of water. Because of this composition, the scientists posed the following question to themselves. Pluto's gravity and surface temperatures allow pure methane ice to sustain such steep formations over long geological periods. Perhaps the telling answer is that the few studies that have been conducted in this regard thus far paint completely different pictures. One theory is that the snakeskin terrain is made up of methane hydrate. Some studies strongly suggest that this ice-like substance formed in the interstellar medium before becoming a component of the solar nebula. In other words, methane hydrate may be one of the solar system's oldest materials. At first glance, the image of Pluto's night side appears to reveal few details. But this is not the case because the sun is hidden behind the secluded astronomical world, plunging its backside into impenetrable darkness. In the dim light, we can see a crushing-shaped area on the upper part of the celestial body, revealing the shadowy landscape formations. The natural atmosphere, in the form of a multi-layered nebula complex, is also clearly visible in this dim image at the time of the photograph. New Horizons was about 12,000 miles from Pluto at the time. Now it's your turn to tell us which Pluto image captivated you the most. Drop in the comment section below with your thoughts, suggestions, and feedback on today's video. With that being said, that's all for today. Thank you for spending some time with us. If you found this video interesting, make sure to hit the like button and the notification bell and subscribe to our channel to get access to more interesting videos from us. Till next time.